Welcome to the next lecture in electric circuit analysis. We were discussing the two-port network. In the previous lecture, we have seen the impedance parameters, and in this particular lecture, we will focus our discussion on admittance parameters. We have seen in the previous lecture that certain two-ports network will not have the Z parameters. So Z parameters will not exist for certain two-port network. We have taken the example of an ideal transformer, and it was explained that the Z parameters of an ideal transformer do not exist because it is impossible to express the voltages in terms of the current and vice versa. We have seen in the two-port network that in the two-port network we will be having the terminal quantities as the voltages and the current, and the voltages has to be dependent on the current and current has to be dependent on voltages. Then only it is possible to obtain the Z parameters. But for an example such as ideal transformer, Z parameters do not exist. So ideal transformer will not have any Z parameters. Then there is a need for an alternative means by which we can describe such networks whose Z parameters are not available. These need may be met by a second set of parameters which we obtain by expressing the terminal currents in terms of the terminal voltages. So other set of parameters which will relate the voltages and the current, which is the topic of discussion for today, that is the admittance parameters, will meet our requirement. The terminal currents expressed in terms of the terminal voltages, considering that the currents I1 and I2 are the dependent variables, then we can write the expression for the terminal currents I1 and I2 in terms of the terminal voltages V1 and V2 in terms of the admittance parameters. This is in accordance with the current is equal to admittance into voltage. So the current at the terminals are represented by I1 and I2, and the voltages V are represented by V1 and V2 at the terminal. So in the matrix form, these two equations can be represented as the current matrix I1 and I2, or the vector, is equal to the admittance matrix multiplied with the voltage vector. So I is equal to Y into V, where the set of parameters Y, which are given by Y11, Y12, Y21 and Y22, are known as the admittance parameters. So the admittance parameters, or simply we say that Y parameters, have the unit of Siemens because it is the reciprocal of the impedances of the network. Now these Y parameters are evaluated by setting the input voltage to be 0 or output voltage to be 0. So when the voltages are 0, it means it is a short circuit condition either at the input port or at the output port. Now we can obtain the data Y11 and Y21 by creating the output port V2 to be 0 or short circuit, connecting the input current source I1. So we can obtain the values of Y11 and Y21 keeping the output port short circuited V2 0 as the ratio of the current I1 by V1 and I2 by V1 for Y11 and Y21. Similarly, if we need to find the values of Y12 and Y22, we will be short circuiting the input port by using V1 to be 0, connecting the source at the output port I2, and we can obtain the values of Y12 and Y22 is equal to I1 by V2 with the input port short circuited and I2 by V2 with the input port short circuit. So in this way we can obtain all the parameters And in these Y parameters, which are generally obtained by short circuiting the input or output port, these terms are generally defined as, for example, Y11 is known as the short circuit input admittance. Y12 and Y21 are known as the transfer admittance short circuited from port 2 to 1 and from port 1 to 2. And Y22 is known as short circuit output admittance. So Y11 is the input impedance admittance and Y22 is the output admittance. Another one is basically the transfer admittance. Certain remarks which relates it with the impedance parameters is the impedance parameter, that is the Z parameter, and the admittance parameter, that is the Y parameters, are together collectively referred to as immittance parameters. Second, the conditions of symmetrical and reciprocal network that we have discussed in the impedance parameters topic remain the same as we have discussed in the previous lecture. Now here, when the terms Y1, Y12, Y21 are obtained, then the pi equivalent circuit for the reciprocal case only can be obtained. So this is the pi equivalent network which represent a two-port network with the associated terms. And for a general equivalent circuit, we can have a dependent current source connected at the input and dependent current source connected at the output of a two-port network. So we can obtain the equivalent circuit of a two-port network in terms of admittance parameters for the reciprocal case as well as the general case. Let us solve one problem. So in this network, we have to determine the parameters, Y parameters. So we have to determine Y11, we have to determine Y12, we have to determine Y21 and Y22. These parameters are basically known as Y parameters, which we need to find. How to find for this particular case? So this is my input port and this is my output port. So first we need to find the parameters Y11 and Y21 as discussed by short circuiting the output port. So here we have the output port which will be short circuited and a source will be connected at the input side, which is I1, and we will obtain the parameters Y11 and Y21. So obtaining V1 from the input side, we are finding that it is 4 by 3 I1 and Y11 is nothing but the current at the input port divided by the voltage at the input port with V2 to be 0, which comes to be 0.75 Siemens. So we are getting this from the first equation. Similarly, we can obtain the value of Y21 in terms of I2 by V1, keeping the value V2 to be 0. So we have to relate the current I2 with respect to I1 and put it in the second equation. So we'll get Y21 is equal to minus 0.5 Siemens. The other two terms Y12 and Y22 can be obtained by short circuiting the input port. This is my input port which I will be short circuiting, and I will connect the current source at the output terminal. So we can determine the parameters Y22 and Y12. Both the parameters we will determine as the ratio of I2 by V2, considering that V1 is equal to 0 and I1 by V2 considering that V1 is equal to 0. So we will do some calculations as given in the circuit theorems rules that we have studied. So we'll get 0.625 Siemens here, and here we'll get minus 0.5 Siemens. Once we have obtained all the parameters Y11, Y12, Y21 and Y22, we can put it in the form of a matrix, and this is the Y parameters which we were solving. So this completes the Y parameters, and the previous lecture we have discussed the Z parameter. In the coming lectures we will discuss the other type of parameters for the two-port network. Thank you for now. See you in the next lecture.